Welcome to Totally Integrated Instrumentation. We're going to take a look at the Siemens electro-pneumatic valve positioner, the PS2. And this particular version is the new version with the built-in pressure transmitters, but we're going to look at, to start off with, some features that were available on the older version that didn't use the built-in pressure transmitters. And it's the valve performance tests that we're interested in, and you can see here in the background that PDM logs all of these. So really, this information is available for digitalization to get it up to the cloud, but they are manual tests. Now, the important thing with any device that's got a built-in logger, as you can see here, my time and date stamp, when I did it, I didn't have the date and time set. So if we go to operation, and you can see there date and time in device, PS2 has a real-time clock on it. I've already set that, but you can set the date and time by clicking this button here. And then when you've done that, you're ready to run the four wizards to populate this information. And the beauty of this is, if you're a valve OEM, you can run all of these tests and save this and print this out as part of your documentation. All of the valve performance tests are on the wizards, and if we have a look at these one at a time, the full stroke test has a start and end position. You try and do it as over much of the valve travel as you can. I haven't set 100% because I've got some issues at the top end with this valve, so I'm forcing it to pass. And you can see here that it has a full stroke test valid, and these are the results, but it will have the wrong date and time on it, so I want to sync this all up. Now I've set my date. It does make sure that you're reading this, because if you are running the process, this valve is going to fully open and fully close, so really you should be doing this when the process isn't running. You can see here that it's already done that test. So if we go through the options, these are the results that it records, but we can also read the trace, and I'm going to select, I want the set point and the read back. Just for this video, I'm just going to do every 10th sample to make it faster, and here I can see the response of my valve. Blue is my set point and the red is my actual position. Okay, so that is my full stroke test. I can print that out from here, but the results, like the settling times and everything else, are already recorded, and that's the information that is critical going forward with digitalization. So we'll finish that one. We'll look at the next test. We've got a step response test, and in here you can put any position you want. I'll keep it at 100% again, and your stroke height, step response time. So I've put this to 20 seconds. I think there's a mistake there with that percentage. So 20 seconds for my time. So this test is going to take a little bit longer, so I'm going from 0 to 100%. So again, here it shows you the test is active. So we can see our results, and here we can see the results of our trend. So we have our 20 seconds here at the front end, and then we can see our settling time and the reached end position. So again, the trend is there, you can print that out, but it's saved in our results. So the next test is the multi-step response test. So this is a little bit more advanced than the first two. So you might want to see how well your valve is reacting to step responses over its complete range. So this is the multi-step response test, and in here you can edit how many steps that you want to do. So I've done number of steps 10, step duration is 4 seconds, and my stroke height step response time is 90 seconds. And again, we can see here that I had a fault because I've got this one going to 100%. So that was previous test end position it was struggling with. So if we start that test, so here we can see the results, and you can see the two areas where I was struggling. So this is a diaphragm valve, so I didn't quite have enough time here to reach 100%. So I'm probably asking it to respond a bit too quick at the top end, and then down here when we're taking the air off, again I haven't given it enough time. Again, that information is stored, and the last test, which can take a while, is the valve performance test. So it runs 22 measuring points. So if we open this up and have a look at what we're doing, so it's done in accordance with this IEC standard. So we're looking at the hysteresis, repeatability, linearity, uncertainty, and total average measurement error. So it does it over a few cycles and takes 20 measurements. So we'll go through this. It can take a while to do this test, so depending on how many cycles that you choose. So here we have the last one was valid, so we're going to start that. Now the test is finished, we can see here the valve performance test is valid, and it's done tests like hysteresis again to the IEC standard. So it has to do a few runs to get repeatability, non-linearity, and there's no surprise here that my accuracy down is better than my accuracy up, and this is because the plastic in my diaphragm, or the PTFE, it's struggling to push that up. So if I knocked the pressure up a little bit, that maybe perform a little bit better. But here I've got all of my results. If I want to look at them in more detail, this will then load each cycle and show me the results. And this again is being saved within your PDM parameter set. If we have a look at our PDM parameter set now, you'll see here all of your online diagnostics, but here these are the results of the valve performance test. So you can go under each one of these tabs and see your results. So here we can see our breakout times for the full stroke test. If I come to my valve performance test, I can see here there's a summary I've hit, so the hysteresis, linearity. If I click on this, it will expand that, and I can see all of my results for each one of the runs. So there's certain things you can do to save this. So I'll save it here. It's saved it within my project. If I want to, I can do a file export. So if I export that, it exports it as an XML. And what does that mean? Well, that means that I can open this with any Windows Office tool, so Excel, Word, but it also keeps your HTML mapping, so you can actually open it with a web browser. So I'm not after documents. I'm just going to put this somewhere so I don't have to look for it, and then we will export that. So once you've exported your parameters, you can just double click on them to open them with a HTML driver. In this case it's Windows Explorer, and you have all of your parameters, how it's programmed, and you can see here if you're used to programming the PS2 with the push buttons, these are the parameters that you would see on the display. Then as we start scrolling down, once we get past these parameters, we'll start getting to our diagnostic settings, and then you will see here your valve performance test. So this is a full stroke test, and all of your results are there. So if you have maintenance station as your data collector, and With that, you have the option to read your parameters within PDM once a day and then send that information off to an app. This data will stay the same for the majority of the time until you reperform those tests, and you'll see your before and after results. So it's just another set of diagnostic values that really enhance the remote diagnostic function of this SIPART PS2, which will give you better indication into how your mechanical assets are functioning. So I hope that proved useful. Thanks for listening. Please share this channel with your friends and colleagues, and thanks for your support.